Hi guys, so today we're going to review a little bit more geometry, but we're also going to look at something new at the end. Today we're going to review our trig ratios. So you may remember the acronym SOHCAHTOA from geometry. That is what we're going to look at today. So this is really getting us started into our trigonometry section of pre-cal. So trigonometry is just a fancy word that basically means we're looking at the relationships of sides and angles of triangles. Okay, so it's kind of relating back to triangles. So what we're going to look at today are our trig ratios. So trig ratios are like the Pythagorean theorem. They only work for right triangles. So we did special right triangles last class, which helps us solve for missing sides. These trig ratios will help us solve for triangles that do not have that special 30-60-90 or 45-45-90 ratio. So if you remember from geometry, the SOHCAHTOA acronym helped us remember those sine ratios. S was for sine, and sine of an angle, I'm going to use theta to represent an angle, you'll see that a lot this year, is the ratio of the opposite side over the hypotenuse of a triangle. C stood for cosine, so the cosine of theta was equal to the adjacent side of the angle divided by the hypotenuse. And T stood for tangent, and the tangent of theta was equal to opposite over adjacent. So what we're going to do to start is we're just going to go ahead and find what these trig ratios are. So on this triangle, I do need to find my missing side first. So I know two sides of this right triangle, so to find the missing side, I can do Pythagorean theorem. Now, one thing you'll see us use a lot are these letters. The capital letters will refer to the angles. The lowercase letter will refer to the side across from it. So the side that we don't know here is D, because it's across from angle D. So D squared plus 3 squared would equal 5 squared. So D squared plus 9 is 25. So D squared is 16. So D is 4. So my missing side here is 4. Now once this is filled in, then I can find these ratios. So we're starting with the sine of angle D. So sine is opposite over hypotenuse. So I'm going to go to angle D, and I'm going to list the side opposite of D, which is 4, over the hypotenuse. And I'm going to go ahead and label the hypotenuse. No matter which angle we're looking at, the hypotenuse will always be 5. It's the one across from that angle. So that ratio there is 4 over 5. All right, cosine is adjacent over hypotenuse. So looking at angle D, the side adjacent to it, the side that touches it, that is not the hypotenuse, is 3. The hypotenuse is still 5. Then tangent is opposite over adjacent. So opposite of D is 4. Adjacent to D, not hypotenuse, is 3. All right, we're going to do the same ratios, but now we're going to look at angle E. So for E, sine is still opposite over hypotenuse. So 3 over 5. Cosine of E is adjacent, so adjacent to E is 4. Hypotenuse is 5. Tangent is opposite over adjacent, so opposite of E is 3. Adjacent is 4. And those are just the simple ways of how we write these ratios. So now what we're going to do is we're going to solve some of these algebraically. Now, whenever we solve these algebraically, you're going to need to make sure you change your Casio's mode. Your Casio is going to need to be in degrees. So the steps to do that, it is from Run Matrix, Shift, Menu, and then you'll scroll down to Angle, and you can press F1 to change it to degrees, and I'll show that to you guys real quick. All right, so I'll go to Run Matrix. And then again, to change this, well, that's what we did last time. I'm going to go to Shift, Menu, where it says Setup above there. Then I can scroll down until it says Angle. Right now it says RAD. That stands for radians. We're actually going to look at what that means after Thanksgiving break. But we're going to press F1 so we can change that into degrees. And that's the mode we want our calculator in to do these calculations that we're about to do. All right, so now that our triangle is set up, we can go ahead and actually solve some of these. So what it means to solve a triangle. Solving a triangle means finding all the missing sides and angles. And like we just said, the lowercase letters are going to refer to the sides, and the uppercase letters are the angles. And specifically, it's the letter will be across from that angle. So side D is across from angle D. To find the missing sides, you use trig ratios, or you also could use Pythagorean theorem if you have two sides. So we can still use Pythagorean theorem. To find the missing angles, we're going to use the inverse function, which is the shift and then the button on our calculator, the one with a little -1. So like sine inverse is the one that looks like that. All right, so let's go ahead and solve our triangles. So it tells me the measure of angle E is 26, so I'm going to label that. It tells me side C is 14. So side C is across from angle C. And that is my hypotenuse. I'm going to go ahead and label it as H, because hypotenuse does not change. The hypotenuse is always the hypotenuse. All right, so now we're going to solve for one of our missing sides. All right, let's start with solving for side E. Side E is across from angle E. So I need to figure out which trig ratio I'm going to use. Well, 26, I'm going to have to use the one that has an H, because there's an H here. The side that I'm looking for is opposite. So I'm going to use opposite over hypotenuse, which is sine. So sine 26 is equal to opposite over hypotenuse. Once you have your ratio set up, all you have to do is solve. So I can multiply both sides by 14. And then at this point, you would just plug it into your calculator. And when I plug that in, I get 6.14. So that is side E. All right, now let's set up a new ratio to solve for side D. So side D is across from angle D. So again, I need to determine which one I'm going to use. So I'm going to use that angle. D is the adjacent side, H is the hypotenuse. So the one that uses A and H is cosine. So cosine 26 equals adjacent over hypotenuse. Again, to solve, multiply both sides by 14. Plug that into your calculator, and you'll get your answer. I actually have to plug it in. I get 12.58. So now I know my two missing sides. The only other thing I don't know on this triangle is angle D, which is actually really easy in this case because the angles of a triangle add up to 180. So 180 minus 90 minus 26 gives me my missing angle. So angle D is going to be 64 degrees. And now again, if we use what we talked about last class, this makes sense because the bigger angle is across from the biggest side. The smaller angle is across from the smaller side. All right, let's try B, or example B. It tells me angle E is 32 degrees. It tells me side E, which is across from angle E, is 11. So now that this is filled in, let's solve for our missing pieces. All right, so I'll start by trying to find side D, which is across from D. So I need to figure out which trig ratio to use. Well, I'm not using the hypotenuse. I'm using the opposite and the adjacent for 32. So I'm going to use, tan, because tan is opposite over adjacent. So tan 32 equals opposite over adjacent. Now this one's a little bit harder to solve because we can't just multiply both sides and be done. Now we could multiply both sides by D, but we still have to solve for D. So then I have to divide. So whenever you divide on these, you'll always divide by the trig function. All right. So at this point, you can go ahead and plug this into your calculator. And I end up with side D being 17.60 as my side. All right, let's find our other missing side. All right, that is across from angle C, so that is side C. So let's figure out which trig ratio we're going to use. Well, C is the hypotenuse, and then 32 and 11, those are opposite. So opposite and hypotenuse, that is sine. So sine 32 is 11 over C. So we'll go ahead and multiply both sides by C, then divide by sine 32. So at this point, we can plug this into our calculator. So I will do 11 divided by sine 32. And I get 20.75. I'll round that up to 720 point, oops, we'll go two places. 7.76. All right, and again, we don't know angle D, but that's really easy because those are going to add up to 180 total. So I can just do 90 minus 32, which would give me 58 degrees. And again, the bigger side is across from our bigger angle. And the hypotenuse is the biggest side as well, which also makes sense. All right, so this next one's a little bit different because on this next one, I only know two sides. I don't know any angles. So let's go ahead and fill in what we know. Side C is 109, side D is 91. So if I want to find that missing side, which is side E, I can use Pythagorean theorem. So E squared plus 91 squared equals 109 squared. So I'll go ahead and plug in these values. So 91 squared will give me 8281. 109 squared, it's going to give me 11,881. I'll subtract, and I end up with E squared is 3600. I'll take the square root of both of those things, and that should be 60, but I'm going to double check on my calculator. And that is 60. So my missing side is 60. All right, so what we can do now is we need to find our angles. So remember, we said if we need to use angles, we're going to do inverse, okay? So I'll start with angle E, okay? We'll use the two sides that it gave us. So the two sides that it gave us in relation to E are the adjacent and the hypotenuse. So adjacent and hypotenuse, I'm going to use cosine. So cosine E is 91 over 109. So the way we figure this out, we don't divide, okay? We use inverse. So cosine inverse of 91 over 109 is equal to E. So cosine inverse on your calculator, it's shift cosine, and then you can plug in that fraction. So it's 91 over 109, and I need to plug that in on mine. And I get 33.4 degrees. All right, now if you wanted to at this point, you can just subtract from 180, but I'm going to go ahead and set up a trig ratio as well to find D just for the practice, okay? So if I'm doing D, 91 is opposite, 109 is hypotenuse. So this would be opposite and hypotenuse. So the sine of D is going to equal 91 over 109. So I would do sine inverse of 91 over 109 on my calculator. And you'll notice it's going to be the same thing as if you were to subtract this from 90. But again, it's just good practice to go ahead and set this up again. So 91 over 109. And I end up with 56.6 degrees. All right, if you feel comfortable, pause the video, try this last one on your own. All right, so let's go ahead and do this next one. So side D is 6, side E is 8, and we can use Pythagorean theorem to find our missing side. I'll go ahead, though, and just find our ratios, or I'll find our angles before we do that. So let's go ahead and find angle D. So for D, we've got our opposite and our adjacent. We don't have the hypotenuse, so we're going to use tangent. So the tangent of D is opposite over adjacent. So to solve for the angle, we use inverse. So tan inverse of 6 over 8. I'll actually plug that into my calculator. And I get 36.87 degrees. If I want to set it up for E, again, you could just subtract from 90. But if I want to go ahead and find it, I'm going to use tangent again. Opposite over adjacent. So tan E is going to be 8 over 6. So tan inverse of 8 over 6. Plug that into your calculator. And let me plug that one in. That's 8 over 6, which is 53.13 degrees. And again, those do add up to 180 like it should. To find my missing side, we'll use Pythagorean theorem. So we're looking for C. So 8 squared plus 6 squared is equal to C squared. So that's 64 plus 36, which is 100. So C is 10. And now I know all my missing sides and missing angles. All right, so same thing, we're just gonna look at a word problem now. So we've got a 12-foot ladder leaning against a wall. So the ladder makes a 65-degree angle with the ground. So here's my ground, this is my ladder, and this is my wall. So here's your little house if you want to draw it that way. There's a ladder. All right, so there is my picture. So I want to know two things. One, how far up the wall the ladder reaches. So what I don't know, that's the height. That's how far the ladder reaches. So let's find this one first. We know the ladder is 12 feet. So with 65, that's opposite and hypotenuse. So opposite hypotenuse, I'm going to do sine. So sine 65 equals opposite over hypotenuse. Multiply both sides by 12. And then at this point, you can just plug that into your calculator. So that's 12 times the sine of 65, which is 10.88. And then it was feet, so this is feet. So that's how high up the wall it goes. All right, let's see how far the bottom of the ladder is away from the wall. That's going to be, we'll call that y. All right, so to find that one, we'll use adjacent, because y is adjacent in hypotenuse. So this is cosine. So cosine 65 is y over 12. Multiply both sides by 12. So I have 12 cosine 65. And I get 5.07 feet. All right, so now for the new part. So in addition to the trig ratios that you guys have learned all along, each one of those has a reciprocal. Now reciprocal is different from inverse. Okay, inverse we do a different operation. Reciprocal is with it flipped. So we have SOHCAHTOA if it's our normal trig ratios. We also have this CHO, SH, COW if it is the reciprocals. So what these are, each one is a reciprocal of one of the trig ratios that you already know. Cosecant is the reciprocal of sine. So it's the sine ratio but flipped. So cosecant, CSC, that's our abbreviation, is hypotenuse over opposite. It's the same thing as sine but flipped. Secant, or abbreviated SEC, is the reciprocal of cosine. So that is hypotenuse over adjacent. And then cotangent is the reciprocal of tangent. So cotangent is abbreviated COT, and it is adjacent over opposite. So it's the same things but flipped. Each of these kind of pair up, and I think the most confusing thing is that cosecant does not go with cosine. But the way I like to remember it is that each pair has one co. So you've got cosecant with sine, cosine with secant, and cotangent with tangent. Most people remember that one. So each one has a reciprocal. So sine is the reciprocal of cosecant. Cosine is the reciprocal of secant. Tangent's the reciprocal of cotangent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So what we're going to do here is we're just going to find these ratios the same way we did in the first problem, but we're going to find the new ratios. So first I need my missing side. So let's do Pythagorean theorem. 5 squared plus 4 squared is c squared. So 25 plus 16 is c squared. So that's going to be 41 is c squared. So c is the square root of 41. All right, so we'll do cosecant of d. Cosecant is the reciprocal of sine. It is hypotenuse over opposite. So hypotenuse is root 41. Opposite of d is 4. Secant of d is hypotenuse over adjacent. So that's root 41, and adjacent to d is 5. Cotangent is adjacent over opposite. So adjacent and opposite is 5 over 4. All right, same thing for E. If you feel comfortable, pause the video, try this one on your own. So cosecant, hypotenuse over opposite, that's root 41 over 5. Secant is hypotenuse over adjacent, so that's root 41 over 4. Cotangent is adjacent over opposite, which is 4 over 5. All right, so the last thing we're going to do is just not really all that complicated, but the directions can be a little bit confusing. So this tells you that secant of theta is 13 over 12. Now we are going to do this without a calculator because it's kind of hard to type in secant into a calculator. So what we're going to do is we're going to draw a triangle. Right? You can draw this triangle however you want. Make sure it's a right triangle though, and put theta somewhere on this triangle. I'm going to put theta right here. Secant is our reciprocal of cosine, so it's hypotenuse over adjacent. So what I'm going to do is I'm going to fill in my triangle based on how I drew it. I made my theta there, so my hypotenuse is 13, my adjacent is 12. Well, now I can do Pythagorean theorem to find my missing side. And if you remember those Pythagorean triples, this is one of them. So my missing side is 5. Well, now that this triangle is filled in, I'm just going to find sine, cosine, tangent for the triangle that I have drawn. So I don't need to change anything. I just draw that triangle and I keep it consistent for this problem. So opposite over hypotenuse on that triangle is 5 over 13. Adjacent over hypotenuse on that triangle, 12 over 13. Opposite over adjacent. And we're also going to find cosecant. Secant I already have, that's from the original problem. And cotangent. So cosecant, hypotenuse over opposite. Cotangent, adjacent over opposite. All right, let's try one more of those same questions. So again, I'm going to draw a triangle, any triangle. Make it a right triangle, draw theta somewhere. Okay, here is my theta. Fill in your triangle based on how you've made that theta. Cotangent is adjacent over opposite. So adjacent to theta is 2, opposite of theta is 3. Now that my triangle's filled in, I can do Pythagorean theorem for my missing side. So that's going to be the square root of 13. Now all I do is I find those ratios based on my picture. So opposite over hypotenuse is 3 over root 3, or root over 13. And then we're going to rationalize like we did last class. And I have sine theta. Cosine theta adjacent over hypotenuse. Rationalize. Tan theta, opposite over adjacent. We'll do our reciprocals. So cosecant, hypotenuse over opposite. So root 13 over 3. Secant theta, hypotenuse over adjacent. And cotan theta, adjacent over opposite. And those are your trig ratios. All right, guys, so that is it. I know it's kind of a lot for the break, but hopefully most of the geometry stuff was review for you guys. The biggest new thing to know is just your cosecant, secant, and cotangent ratios.